Sea level rise is one of the biggest threats for coastal communities across the globe. And in many places, while the sea level is rising, the land is sinking. We call that vertical land motion. And that vertical land motion, we don't have a lot of measurements of. Over the last couple of years, decades, there is some data, but we don't have very long, spatially high-resolution data sets that would allow us to study how this signal of vertical land motion has evolved over time. In our recent study, we were able to use tide gauge data to reconstruct this vertical land motion signal for the last several decades, 100 years, in some places more than 120 years. And that showed that this vertical land motion signal is in fact highly nonlinear. There are phases where land subsidence happens very rapidly, thereby massively increasing the effects of sea level rise. And that can be the result of natural processes such as earthquakes, tectonic activity, but in many cases it's a result of human activity, from extracting ground fluids such as pumping groundwater, extracting oil and gas, which then leads to compaction of sediment and sinking of the land surface. And in our assumptions for future sea level rise projections, which are the basis for many coastal management plans, we also rely on this idea of vertical land motion being a linear process. So what our study now shows is that there are uncertainties associated with these assumptions, and we now can put numbers on those uncertainties. And that is a very important first step to better integrating vertical land motion into future sea level rise projections to make sure that our coastal communities are safe and resilient even under the threat of sea level rise.